7.6, Bayes' theorem. Bayes' theorem is a formula, and it looks really intimidating, I think, with all of this stuff. All right. But at the end of the day, it turns out that it's just talking about part over total. Once you figure out that Bayes' theorem is just talking about part over total, it'll make a little bit more sense to you, I think. Okay. Bayes' theorem helps us find probability of A given B. It helps us find some conditional probability if we already know the reversed conditional probability. So I can find probability of A given B if I know probability B given A. That's going to be a huge indicator that it's a Bayes' theorem problem. Okay, so how do I know when I use this formula? I use it when I'm finding a conditional, but they give me the opposite conditional, or the backwards, the reversed conditional. That's kind of your clue. It's a huge clue. So let's look at this problem. For a fixed length of time, the probability of a worker error on a certain production line is 0.1. The probability that an accident will occur when there is a worker error is 0.3. And the probability that an accident will occur when there is no worker error is 0.2. Find the probability of a worker error if there is an accident. All right, now, a lot of stuff going on here, a lot of words. One of my plans of attack on a story problem is to turn it into a non-story problem. So I'm going to go back through here and just kind of write down what they give me and try to take out all the words, all the context. So let's see what they've got. Okay. Probability of a worker error on a certain production line is 0.1. So the first sentence gives me this. Probability of an error equals 0.1. I keep reading. It says the probability that an accident will occur when there is a worker error is 0.3. So I want you to look at that. An accident will occur when there is a worker error. You've got two different kind of things happening. There's an accident and there's an error. And so I think you need to think really hard about which happens first. Okay? Does the accident happen because there is an error, or does the error happen because there is an accident? Which came first? The error. And so we can say that we're finding the probability of an accident given that there was an error. And you need to think really hard about what those words mean. And that was 0.3. Continuing, the probability that an accident will occur when there is no worker error is 0.2. So that's kind of the same deal. We're finding the probability of an accident given that there was no error. So remember the little complement symbol.
Can you just write like probability of an accident equals 0.2, or do you have to include given that there's no error?
Well, probability of an accident is not 0.2, okay? You'd have to say probability of an accident given that there's an error or not an error in order to be fully descriptive, and also to see how it fits into the equation that we're getting ready to use, okay? So good question. And then, let's see, we're trying to find, notice we're trying to find the probability of a worker error if there is an accident. So we're trying to find the probability that there's an error given that there's an accident. And so if I write it down like this, first of all, this is my hint that this is Bayes' theorem. See how we're asking about error given accident, but they give me accident given error? When you see it flipped around like that, that is a huge hint that it's going to be Bayes. So when you look at this equation, all of this stuff right here on the bottom that looks so intimidating, all that is it's talking about all of the stuff in the problem, okay? Everything that's happening in the problem. And usually there's going to be like, let's say there's 3 things in the problem. And so you're going to have to kind of list out each of those 3 things that happen in the problem. Okay, 3 companies are going to do something. So company 1, company 2, company 3, whatever. Everything that happens in the problem. If you look at the numerator, kind of here's where I would start. So look at the relationship between these letters. This first letter happens to be this first letter right here. And then this is the reverse of these two letters. So pay attention to kind of the patterns that happen in the equation. So I'm going to abbreviate here. We're finding the probability of an error given an accident. So I just kind of abbreviated there just to save some space. But think about this problem and think about everything that could happen in this problem. Well, they're talking about two things. Either you have an error or you don't have an error. Okay? Either there's an error or there's not an error. That's really it for this problem. And so if there's two things that they're talking about in this problem, then that means there are going to be two things added up on the bottom of this fraction. So, looking at the formula, you're going to have a fraction with I draw a huge fraction bar, okay? Because you're going to have a big looking fraction. And so again, for the numerator, you look at these two letters, and I can see that this one is going to match the first letter. So my numerator is going to have a probability of E times the switched around conditional, A given E. That's my numerator. Now, one thing that is always going to happen is you're always going to have that same thing on the bottom. One of the things added up on the bottom is going to be identical to the thing added up on the top. Okay? So if you think about it, okay, the two things involved in this problem are, is there an error or is there not an error? Okay? So far I've got represented the case that there's an error. Now I have to represent the case that there's not an error. So what I'm going to do here is mimic the patterns that I've already seen, okay? So I'm going to have probability of not an error times probability of accident given not an error. And so if probability is part over total, all I have to do is get the part that I'm looking at over all of the stuff in the problem, and that's it. Okay, that's what's going to be involved in this problem. That's my Bayes theorem formula. The rest of this is just filling in numbers and doing some calculations. So probability of an error is 0.1, so we can fill it in there and there. Probability of accident given error is 0.3, so I can fill that in. Probability of not an error wasn't given to me, but it sort of was. If we know the probability of an error is 0.1, then we should be able to figure out the probability that there's no error. And what is that? What? 0.9. And so even though they didn't give me that information, I can figure it out relatively easily. Probability of no error is 0.9. And then probability of accident given no error is 0.2. So clean up your numbers a little bit. You've got 0.1 times 0.3 over 0.1 times 0.3 plus 0.9 times 0.2. Sorry, what? No, those aren't going to cancel. Those aren't going to cancel because that's a great idea, and I'm sure you're not the only one that has that idea. But if you think about it, if in algebra, if you had like 2 over 2 plus 3, that's 2/5, right? You can't cancel that and say that it's 1/3. That's not how canceling works. Because of order of operations, you have to add that before you can do this division. That's how that's how order of operation works. Okay, so because of the plus sign, you can't cancel the 0.1, 0.3. Great idea though. All right, so 0.1 times 0.3 is 0.03, and 0.9 times 0.2 is 0.18. So what? I've got 0.03 over 0.03 plus 0.18. That's 0.21. So 0.03 over 0.21 is 0.1429, I guess. Or if you notice, it's about 0.1429. I'm not sure if you're going to have to round off, or if you notice, that's 3 over 21, which reduces to 1/7. So it's exactly 1/7, or it's approximately 0.1429. Either way, that's the probability of E given A. Probability of E given A equals 1/7.